Hey ProbStats kids, this is Dr. Callahan with week 6 Friday. I hope you guys are having a great Friday and a good week. So go ahead and pause the video and take a look at the 3 questions for the warm-up. Keep in mind that this is week 6 Friday. Your warm-up log for 300 points is due on week 9 Friday. So you have exactly about 3 more weeks before this is due. Just to give you a quick recap of what the 300 points will be for, 100 is going to be out of participation. So that's essentially of you checking in with me on the YouTube channel, you being here on time, in person, and basically just participation in the class and completing your to-do list when I see you guys. 100 is for preparation, meaning that you are prepared for class, as in you have your white unit packet, you have your green warm-up log and ready to go every day, and then 100 boxes of your warm-up. When I saw you guys last time, we talked about empirical theoretical probability with charts, with band numbers, with lottery tickets, and you guys had a few homework questions from, this is from week 6, Thursday. You can find the textbook or a picture of the textbook for your homework assignment on the Google Doc under week 6, Thursday. And you had questions 2, 4, 6, and 18. And the points are as follows, so take a look at that. This should always be on the back of your white unit packet, because on your white unit packet, you have your homework template. And this should be on that. So when you turn in a unit packet, I will have this available. We went over objective 9 in class, so right now what I'm going to do is I would like to go over objective 10 with you guys. So let's go ahead and take a look at this. All right, with objective 10, take a look at the following 3 questions. It gives you a standard 52 deck of cards. Find the following if the poker hands consist of 5 cards, okay? So remember the 2 numbers. These are the 2 numbers. In is always a bigger number that goes in the denominator. And your in this case, or excuse me, your R in this case is going to be 5 because it is a smaller number, and it's also going to be in the numerator. Okay? So A says the total number of possible 5-card poker hands, which means it is going to be a combination because order does not matter. And with your combination, you're going to have 52 here and 5 here. And the formula for this is going to be n factorial over n minus r factorial times r factorial, which is going to be 52 factorial over 52 minus 5, which is going to give you a 47 times 5 factorial. So then if I go ahead and extend this, what's going to end up happening is I'm going to have 52 times 51, 50, 49, 48 times 47 factorial. And I want to stop there because I'm eventually going to cancel it with the denominator of 47 factorial. But then don't forget your 5 factorial because you won't be canceling that anytime soon. So make sure you extend that out. So then if you take a look over here, your 47 factorial cancels. Gone. And then you want to compare your numerator and denominator, see that maybe you can cancel a few things. Well, I know that with my 51 and 3, I can cancel that because that will give me a 17. With my 50 and 5, 50 divided by 5 is going to give me a 10. 10 divided by 2 is going to give me a 5. 48 divided by 4 is going to give me a 12. So then what I'm left in the numerator is 52 times 17 times 5 times 49 times 12 over 1. And if you have a pretty awesome calculator, you can go ahead and multiply that out. And that is going to give you a combination of 2,598,960. So this is my answer of all the possibilities of 5-card poker hands in a deck of 32 cards. With B, what is the probability or what is the outcome of a diamond flush? So all 5 cards are going to be a diamond. So in this case, let's think about all of the diamond. How many cards are diamonds in a set of 52? That's 13. Remember, there are 4 suites, and they are hearts, spade, club, diamond. And remember, there are 13 of each. And if you add all 13 up, 13 times 4 is the total of 52 deck of cards. So for just a diamond, all of the diamond is going to be 13. So then your R is going to be your want. So that is going to be how many cards are going to be diamond. And here it's asking for 5. So that's going to be my R. So let's go ahead and take a look at our formula. So C, 13, 5 is going to equal to 13 factorial over 13 minus 5, which is going to give you an 8 factorial times R factorial. So let's go ahead and extend this over. 13, 12, 11, 10, 9, 8 factorial, and actually you could stop right there because you will have an 8 factorial on the bottom, but then don't forget your 5, 4, 3, 2, 1. Okay, so next what we're going to do is I'm going to cancel out the 8 factorial, and we're going to go ahead and reduce everything. 10 divided by 5 is going to give me a 2. This 2 is going to cancel the 2 in the denominator. 12 divided by 4 is going to give me a 3. 3 divided by 3 in the bottom is going to cancel out. And I am left with a 13 times an 11 times a 9. And that in itself is going to give me 1,287. So in a diamond flush, where all 5 cards are diamonds, in a deck of 52 cards, it is possible to have 1,287 different variations. First, see the probability of being dealt a diamond flush. So whenever it says something about a probability, remember the probability of being dealt a diamond flush. Okay, anytime there's a probability, there is a fraction where the top is going to be your want and the bottom is going to be your total possibility. And in this case, it is going to be whatever your answer was in B divided by your answer in A, which was 1,287 divided by 2,598,960. And if you go ahead and divide that, it is going to give you a 0.00495, or if you go ahead and convert that into a percentage, oh, you know what? I'm missing one more. Sorry. I'm actually missing one more 0 in front of this. So let's try that again. 0.000. There we go. So if you're going to convert this from a decimal to a percent, you just move 2 decimals to the right. So 0.0495% is your answer. So if you are a blackjack player and you want to know what is the probability of you getting a diamond flush, which is 5 cards are all diamonds, or actually, yeah, that is. I don't play poker, but that's okay. I'm not quite sure what this is about. So anyways, the chance of that happening is less than 1%. It is 0.04 or 0.05%. So anyways. All right, let's go ahead and move on forward. So today, this is your breakdown of your assignment. We completed page 9. I'm going to go over one more example on page 9, example 3. And then I have 2 sides of a worksheet. The first one is you practicing this concept with a deck of cards. The second one is a worksheet of practicing probability and the total number of outcomes with a coin toss. Your homework tonight is going to be 11.5, number 8, 4, and 20. It is going to be for week 6, Friday, on your Google Doc. So make sure you find the picture of the textbook there. All right, so this is your assignment. And if you take a look at this right here, if you don't have a copy of this, because I know for some of the classes I did pass this out, but if you don't have a copy of this, you're welcome to just show your work on a separate piece of paper and then turn it in when I see you guys on Monday. On the back of this is going to be your questions on cards, so make sure you guys do the same thing. You can go ahead and pause this so you can answer the following questions. All right, so I'm gonna have you guys next go over the last example that I wanna go over in class, and that is example 3, and it's on page 9. All right, so a club consists of 5 men and 7 women. 3 members are selected at random, so the number 3, number 5 for men, 7 for women. The members are selected at random to attend a conference. Find the probability that the selected group consists of, and there are 2 parts, A for 3 men, B, 1 man and 2 women. Since these are selected at random, order does not matter. So you will be dealing with combination. And then just to reiterate, your combination formula is n factorial over n minus r factorial times r factorial. All right, so for A, if it consists of 3 men, okay, so your R is going to be 3. N is going to be the bigger number. How many guys are there all together? Well, there are 5, so your N is going to be 5. So then what I want is I want to do a combination 5 with 3. So that will be 5 factorial over 5 minus 3 factorial times 3 factorial. So then when I extend this, I have 5 times 4 times 3 times 2 times 1, 2 times 1 times 3 factorial, and my 3 factorial, which actually is this part right here, but I just extended it, cancels. It's completely gone. There you go. And then I'm left with 20 divided by 2, which is just going to give me an answer of 10. So if you were to pick 3 guys out of 5 men, how many different variations are there? How many different ways that you can arrange that? It is 10 different arrangements. Okay. For B, what is the probability of having 1 man and 2 women? So with this one, you would have to go ahead and set it up in 2 different problems. And as I'm looking at this, let's go ahead and set it up like this. So think about that. How would I go about setting that up? And I would like to go over this with you guys, except it's not allowing me to go on to the next slide. I feel like I made so many videos that my laptop is now broken. Okay, well, that's okay. I guess we'll just go ahead and stay on this page. So 1 man, 2 women. So let's go ahead and just do that problem here. So your plan is the first, use a combination of 5 and 1 because this is the 1 man, okay? That's the first part. You're gonna pick 1 guy out of 5 that's available. And then your second plan is going to find the probability of finding 2 women out of the total of 7 women. So with the first one, it is going to be 5 factorial over 5 minus 1 factorial, which is 4 factorial, times 1 factorial. So that's 5 times 4 factorial over 4 factorial times 1. That cancels, so it's just 5, okay? So there are 5 different choices of picking 1 guy out of 5, which makes sense. It's 1, 2, 3, 4, 5, so it's just 5. So how many different arrangements are there to pick 2 women out of 7? So that'll be 7 factorial over 7 minus 2 factorial is 5 factorial times 2 factorial. So that's 7, 6, 5 factorial, 5 factorial, 2 times 1. The 5 factorial cancels. 6 divided by 2 is a 3. 7 times 3 is 21. So now, what are you going to do with this? You are going to take the 2 here, and you are going to multiply them together. So multiply them, and you are going to get 105. And remember, it's asking you about the probability, so it has to be in a fraction. So it's 105 divided by, what were all the different choices that you had with this? 220, which is going to give you a 21 over 44, which is going to give you a decimal 0.477 or 47.74%. And if you're like, well, Callahan, I'm not quite sure, how did you get that 220 there? Well, that is going to be the total of a combination of 3 people that you're picking because you're selecting 2 women and 1 man. And on the left side of this is going to be a total. So what is a total of men and women together? Well, 5 plus 7 is going to give me a 12. So they do 1 more factorial to get the 220. So that's 12 factorial over 12 minus 3, which is 9 factorial, times 9 factorial, or 3 factorial. So 12 times 11 times 10 times 9 over 9 factorial times 3 times 2 times 1. 9 factorial cancels. 12 cancels with a 3, which makes it a 4. 4 cancels with a 2, which makes it a 2. And you're left with 2 times 11 times 10, which is going to give you 220. And that is the total. 5 times 12, which is 150 or 105, is the want. And remember, with a probability, it's always the want over the total. And therefore, that is your answer, 47.74%. All right, you guys, I hope that made sense for you. I know some of these questions are getting a little bit complicated, and that's completely understandable. So with that said, make sure you guys complete the 2 different worksheets, okay? This is the first one on the cards. This is the second one on the coins. And then your exit ticket today is my cup of tea. I'm not sure if you're a coffee drinker or a tea drinker, but I definitely love seasonal teas. What about today's lesson was your cup of tea that you liked? What about today's lesson was not your cup of tea that you did not like? So go ahead and take a moment and answer that. As always, stay safe and healthy. I will see you guys next time. Take care.